Hello friends, welcome to this new episode 9. Episode 9. In this episode we shall be taking a study of some facts in bearing. Bearing is a topic in maths which actually uses or makes use of some principles from basic plane geometry for the solution of questions in the topic. So we shall just briefly examine some important facts that you just need to be abreast with, have them at your fingertips to empower you solve your questions under bearing and get your answers accurately. So in this particular episode we shall consider some of them, and in other episodes to be released we shall also take a look at some other questions and other necessary things to learn. All right, now let's begin. In bearing questions, most of the shapes that are formed are triangles. So most times we always have our shape to be a triangle, and we have different types of triangles. We will not spend much time on that, but just to mention them, we have the equilateral triangle, and then we have the scalene. We have the scalar triangle. We also have the isosceles triangle, and we have the right angle triangle. There are actually more than three. We have the right angle triangle, and we have also the acute angle, triangle, right angle triangle. So these are the types of triangles we encounter. But I want you to note that in your bearing questions, for these two last types we have here, acute angle and obtuse angle, they always lead us to the use of two important rules in mathematics, which we call sine rule and the cosine rule. So whenever we encounter obtuse angled triangle or acute angled triangle, we should know that actually needs to make use of either the sine rule or the cosine rule in solving our bearing question. But first of all, what's an acute angled triangle? Acute angle is an angle that is less than 90 degrees. So an acute angle triangle is a triangle that has all its angles less than 90 degrees. And obtuse angle is an angle that is greater than 90 degrees but less than 180. Therefore, an obtuse angle triangle is a triangle that has one of its angles greater than 90 but less than 180. That's for an obtuse angle triangle. And just that. Okay, now we move on to what's actually sine rule and cosine rule. So we have to know how to make use of these two rules and when to actually make use of them. Now some students may be wondering, like, when do I use cosine rule? How do I know that it's cosine rule I'm supposed to use now, or it's sine rule I am supposed to use now? Here is the answer to that question of yours. If you are in such category, it's actually simple. This is not something you necessarily have to cram. All right, now there are some occasions that actually arouse the use of any of these two rules. We simply list them, but I will also tell you how best you can recall and know which of the rules to actually make use of. All right, now when you are given a question such that one length and all angles are given. So if you have a resulting triangle, after interpreting your question, after interpreting your bearing question, you will eventually result in a triangle, something like this, or maybe something like this. So well, it will eventually lead you to having a triangle. So let's take this triangle, and it could actually be an obtuse angled triangle or an acute angled triangle. Now when you have just one length given and all the angles, so if you have in your triangle, your resulting triangle, you have all the angles given, and then you just have one length, we'll call it ABC, and then you just have one length given and other lengths are not given. Here you know that you have to adopt the sine rule. Now another condition for which you should use the sine rule is when you are given two sides and just one angle which is opposite to one of the given sides. So if you are given two sides, let's say A and B, and then you are given just one angle, and the angle you are given must be opposite to one of the sides. You can see it must be opposite to one of the sides. So in that case, you can also make use of sine rule. You should make use of sine rule. Thirdly, when you are given two angles and one side opposite one of the given angles. So if you are given two angles also, and then you are given one side which is opposite the given angle, so you can also make use of sine rule for such a question. Okay, now all of these things, do you really need to cram them? Well, in order for you not to cram this stuff, because you also need to recall, you also need to store up the conditions that is necessary for you to engage the cosine rule, so that you won't be confused in the exam or recalling which of them belongs to sine rule or which of them belongs to cosine rule. I will explain it this way and then give you an advice on what you are to do for you to be able to know which formulas actually you are to use between the sine rule or the cosine rule. So first of all, we're going to have an obtuse angled triangle of this sort. So assuming you are finished interpreting your question on bearing, and then you have this as the triangle, having drawn it, you have this as the triangle. So you actually isolate it and bring it out so that you can find that length which you are asked to look for. The length you're asked to look for will be one of the sides of the triangle. It will always be one of the sides of the triangle. Even the bearing you're asked to look for, we eventually need to come out from one of the angles of this particular triangle. Hope that's clear. All right, now with the knowledge of that, you have to understand the naming of the sides and the angles in triangles. So you have to understand how the sides are actually named. We have A, B, C. So having something like this, and then you have A, B, and C. Now you have to understand that for every small letter you're having, the angle that belongs to that side or the angle that is opposite that side will be named with the capital letter of that same alphabet. Now the same thing happens for this to this and this to this. So that simply means the side opposite angle A is this side with small letter A. The side opposite angle C is the side with small letter C, and the side opposite angle B is the side with small letter B. You can represent angle A like this, angle A. You can represent angle B like this, angle B, and angle C. You can represent it like this. Now you could also call side. You could also call side A. Side A can be called CB, or line CB, just like this. All right, and then side B can be called CA with these lines beside them, or CA. So this tells us that we're talking about a line. But when we have this particular shape on top of an alphabet, we know that we are referring to the angle. Hope that's clear. Now when you understand this, then how do you know when to use sine rule or cosine rule? I will advise you to work by inspection. Now this means you must first of all know the formulas for sine rule and cosine rule. It is these formulas you should memorize. you don't need to bother yourself memorizing the conditions for you to apply sine rule or the conditions for you to apply cosine rule. I think that is actually kind of unnecessary information for you to be carrying up in your head. If you have enough time to do that, you can memorize it, no problem. But if you are not the type that love to memorize things like that, then first of all, you need to simply understand the formulas for sine rule and cosine rule. Now, the formula for sine rule says A over sine A equals B over sine B equals C over sine C. Good. But now you can't use these three fractions together all at the same time. You can see you're having two equality signs, and we don't actually work with equations that have two equality signs when solving. We just need one. So that means whenever you are to use this formula, you are expected to isolate the two of them that relate to what you are actually looking for. Or the parameters you have. You may have parameters of A and B, then it means you have to use A over sine A equals B over sine B. Or if you have parameters for B and C, then it means you have to isolate this one that has B over sine B equals to C over sine C. Or if you have parameters for A and C, then it means you have to take out A over sine A equals to what? C over sine C, and make use of it. But in all, we only make use of two at every point in time. We make use of just two of these fractions. Hope that's clear. Good. Now then, if we are making use of two of these fractions, it means that we always be required to find either the angle. We always be required to find either the angle or the side. Now let's take a typical example. Let's say we are using A over sine A equals to B over sine B. Now what this implies is that before we can make use of this formula, it means that there must be something we are looking for, and that thing we are looking for can either be A or angle A, or it can be side B or angle B. Remember that this is side A, this small letter A is side A. Now for us to be looking for side A, it means that we must know every other thing that is in the equation. And for us to be looking for side B, it means we must know every other thing that is in the equation. So if a situation happens such that we don't know this and we don't know this, we can't use this equation. Or we don't know this and we don't know this, we can't use this equation. So for us to use this equation, it means that we must have three of these things and one missing. Hope that's clear. We must have three of these parameters and only one missing, and then we are good to go to use this particular equation. So that is what helps you when you are doing your inspection. So it means that by the time you are done with drawing your triangle in your question, now we're going to do this. Now, having drawn your triangle in your question, you are giving this to be 120 degrees and this to be 60 degrees. Okay, no, not 60 degrees. Let's say you are giving this to be okay, let's say 30 degrees. You are giving that to be 30 degrees, and then this other one is 120 degrees. Now, how do you inspect to know if you can use sine rule here? What you simply do is, okay, you ask yourself, now what are we looking for? All right, now we'll have to also put in something here. And now let's assume you are not giving B, you are not giving C, and you are not giving A. So now let's inspect and let's see. So can we adopt the sine rule formula to find side A? Now we are looking for side A. So can we adopt the sine rule formula to find our side A? For us to find side A with sine rule formula, it means we must have A over sine A in our formula equals to. Then we can decide to use B over sine B or C over sine C. So do we have angle A? Yes, we have angle A. That's good. So that's why we even know we can at least start with the sine rule formula. Now, do we have angle C? We have angle C, but do we have side C? So if I say C over sin C, will this work? C over sin C, this will not work. Why? Because we have angle C, but we don't have side C. That means it will not work because we don't have side C. So this means I can't use C over sin C to in combination with A over sin A to form a sine rule formula for which I will use to find side A. Now, can I use B over sin B? Now look at it. We don't even have sine. We don't have angle B. Neither do we have side B. So what this tells us invariably is that you can't use sine rule. You can't use sine rule to solve this question. And if you can't use sine rule, it means that you will definitely need to use cosine rule. Hope that's clear. That's how you simply inspect. So you can know the formula to use by simple inspection. Now this is another case where we are now giving side B. We are giving side B now to be 9 cm, and we are giving side C to be 5 cm. And then we are expected to find angle B. This time around, we are expected to find what? To find angle B. Now, again, by inspection, do you think we can use the sine rule by inspection? Okay, now let's inspect. Now, since we are looking for angle B, it means that our formula should have sine B, because it's only with sine B we can evaluate angle B. So, and for our formula to have sine B, it must also have side B. All right, now we have B over sine of B equals to, the other side can have A over sine A or C over sine C, one of the two. Now, how do we know which of them to bring in now? Is it the A or the C? Now we have to go back to our diagram and inspect again. Which of them are we giving? We have angle A. Good. That shows that at least we think we can bring A in. But do we have side A? We don't have side A. It's not given. So that automatically wipes out the use of A. We can't use A in this formula. What about C? We have side C. We have angle C. That makes C to be qualified. So we simply go to our formula and we bring in C over what? Sine C. And then we impute the values and make what? Sine B the subject of the formula. When we make sine B the subject of the formula, we eventually have sine B equals to what? B times sine of C divided by side C. And so you just put in the values of 30 here, sine 30, and the value for B, which we were given to be 9, rather you place it with 9, and then side C, which we were given to be 5, place it with this, and eventually you will get a value when you do this with your calculator. And then to find the angle B, you take the sine inverse of your answer. So assuming this is an assumption, assuming you do this and you get 0.5 on at the result of this calculation, then B will be what? Sine inverse of what? 0.5. That's an assumption anyway, but I'm just showing you how you can do it. This video is not meant for us to do calculations now. I'm just trying to show you how you can know the formula to select for your calculation. Hope that's clear. And when you take the sine inverse of whatsoever value you get there, you get the value for angle B. Hope isn't that simple and stress free compared to when you have to cram up about 3 things or 5 things in your head for you to know which formula. Then you may end up confusing them.